Moving from a generic subdomain to a fully branded experience requires mapping a tenant-owned domain to your shared software-as-a-service infrastructure. The foundation is a canonical name record created by the tenant that points their chosen hostname to your platform-specific entry point. When a browser requests the custom domain, the server must present a valid certificate for that specific host during the initial handshake. Server name indication allows the browser to specify the hostname it wants to connect to before the encrypted tunnel is even established. Using the Automated Certificate Management Environment Protocol, your system can programmatically request and renew certificates for thousands of unique tenant domains. The HTTP 01 challenge verifies domain ownership by placing a specific token at a known path on the custom domain web server. Domain name system validation is preferred for wildcard certificates and requires adding a temporary text record to the tenant domain zone file. Reverse proxies like Nginx or Envoy must be configured to recognize the incoming host header and route traffic to the correct tenant application. You must preserve the original host header throughout the request chain to ensure the application logic can identify which tenant is being accessed. The application performs a lookup using the host header as a key in a relational database or a fast key value store like Redis. Storing thousands of individual certificates in memory is inefficient, so use a distributed file system or a dedicated secret management service. Deploying an Anycast network ensures that requests to custom domains are routed to the nearest geographic point of presence for lower latency. While subject alternative name certificates allow multiple domains per file, most platforms reach a hard limit of 100 names per certificate.
Certificate authorities impose strict limits on how many certificates you can request per hour, necessitating a queued background job for domain provisioning. The provisioning pipeline involves domain validation status checks, certificate issuance, and finally, updating the load balancer configuration to serve the new certificate. Mapping a root domain or apex domain is difficult because the domain name system standard does not allow a canonical name record at the zone apex. To solve the root domain problem, many modern providers offer ALIAS or ANAME records, which simulate a canonical name at the apex level. Enabling HTTP strict transport security for a custom domain is a permanent decision that forces all future traffic to use secure connections. Your ingress controller should dynamically inject security headers like content security policy based on the specific requirements of the authenticated tenant. Terminate secure sockets layer at the edge to offload cryptographic processing from your application servers and improve overall request throughput. Ensure all internal assets like images and scripts are served over Hypertext Transport Protocol Secure to prevent browsers from blocking content on custom domains. Automated monitoring must track the expiration date of every tenant certificate and trigger a renewal attempt at least 30 days before expiry. Rotate certificates by loading the new file into the proxy memory before discarding the old one to ensure no active connections are dropped. Custom domains are often targets for attacks, so your mapping layer must include rate limiting and traffic scrubbing at the edge. Cache the results of domain-to-tenant lookups in a local memory cache to avoid expensive database queries on every single incoming request. Use webhooks to notify the tenant administration panel once the certificate is successfully issued and the domain is ready for traffic.
Design your application programming interface to handle domain addition validation status polling and manual triggers for certificate renewal. If a domain is mapped but the tenant account is suspended, the edge should serve a branded error page instead of a generic server error. In Kubernetes environments, the ingress controller uses the host field in the ingress resource to map incoming traffic to specific services using server name indication. The Certificate Manager tool automates the entire lifecycle of certificates within a cluster by communicating directly with Let's Encrypt and updating secrets. Scaling to millions of domains requires a sharded reverse proxy architecture and a globally distributed database to maintain low lookup latency. For enterprise tenants who cannot use server name indication, you may need to provision a dedicated Internet Protocol address for their specific domain. Common failures include mismatched common names, expired certificates, or missing intermediate chain certificates, which break the trust link to the root authority. Always bundle the intermediate certificate with the domain certificate to provide browsers with the complete path back to a trusted root authority. Use a scriptable proxy like OpenResty to dynamically select the upstream destination based on real-time lookup results without reloading the configuration. Modern edge platforms allow using WebAssembly modules to perform domain mapping and header manipulation with near-native performance and extreme flexibility. Implement exponential backoff and jitter when retrying failed certificate requests to avoid being blocked by the certificate authority during peak registration times. Provide clear instructions in your user interface showing exactly which DNS records the tenant needs to add to their provider dashboard. The front end should pull a status endpoint to give users immediate feedback as the domain transitions from pending to active status.
Using a single wildcard certificate for all subdomains simplifies management, but exposes all tenants if the private key is ever compromised. Implement automated private key rotation during every renewal cycle to minimize the window of vulnerability for any compromised cryptographic material. Log every handshake failure and domain mapping error to a centralized logging system to identify widespread issues with specific domain name system providers. Enable online certificate status protocol stapling to allow the server to provide proof of certificate validity directly and speed up the handshake process. Future-proof your system by ensuring your certificate issuance pipeline can support hybrid classical and post-quantum cryptographic algorithms as they become standardized. Expect increased CPU usage and memory pressure as the number of certificates grows, necessitating horizontal scaling of your ingress layer nodes. A successful custom domain implementation is entirely invisible to the end user, providing a seamless branded experience through automated infrastructure management. Test your final configuration with tools like SSL Labs to ensure an A+ rating for security and compatibility across all client devices.